Hey everybody. Alright. We're going to play some Arduino today. I don't really know how to jump into this, so we're just going to jump into this. Um, so a few weeks ago, we built model, this model home from Key Studio, and you'll see that, oops, let me bring up okay. We built this model home from Key Studio. We put it all together, and what we're looking at here, we've just we're looking at Arduino. For those of you who don't know, for those of you who know, it's probably going to be kind of boring. But for those of you who don't know, what we're looking at is this little control board. And so this put this on the map over here. This control board is what's powering this house over here, which has been connected to my computer. And I'm actually dragging things around in OBS to make it easier for me to see. So that's why I'm trying to point at things on the screen, but it's not working exactly the way I want. So where we're at now, we got everything connected and working. And what you'll see is like this little red light, that's a motion detector, right? So give it a couple of seconds, it'll come back on. If I put my hand by it, it detects the motion. So that's happened, and if you look, if I push this button, the light comes on. If I push it again, the light goes off. If I push this button, it does nothing. So this is kind of what's going on with this right now. We don't really have here on the back side, our gas sensor light is on. So essentially, we kind of have to go through and make all this stuff work. Some of it kind of works, but some of it kind of doesn't. But the hardest part right here is let's just start with this is what we call a sketch, and it's taken us a while to get everything connected. Um, on Linux, which we're using Ubuntu, we need to use our tools. We use board and input, right? We're going to use this USB 0 serial port, right? And we want this ESP32 dev module. That's the board we want to use. So I'm going to scoot this off to the side, and now we're going to look at this is the instruction for the Arduino board. So we're going to scroll through this. We have 12C communication interface. Don't know what that means right now. Bus 12C. We'll find out. There's analog ports 3.3 volt. That's the same voltage supplied by a lot of your batteries. Like, for example, if I pull this Duracell battery off of here, well, they used to say on there, but apparently it doesn't anymore. But that should read about 3.3 volt per battery. That's why when you run them in series, you end up getting, you know, 2, 2, 2, 2, 2, 2, 2. There's 7 batteries in here. So 7 times 3.3 is going to be about 14. No, should be about 21 volts plus. Um, anyway, we have a P-set button. It's supposed to be a reset button, right? This is our USB entrance. That gives us 5 volts. External power interface, DC, right? So that's where we have our 12 volts coming in from our series batteries. Power input, output, I/O port. So you have power I/O and analog. This is our ESP32 chip, serial communication interface, and 5 volt signals, 14 digital ports. 14 digital ports up here, 14 digital ports down here. Okay, so that's kind of what we're looking at. Now the beauty of this whole thing is it goes through a complete set of instructions how to install this on Windows. When you get your control board, here's how to install it on Windows. This is important. There's a driver, and it's a CH340. In Linux, due to the age of everything, it's now CH341. So this will tell you how to do it with Windows, right? These are all the instructions, and then this is where it tells you to. Now this is all Windows specific up here, but here add the ESP32 environmental, add through version 3. This is all specific to the Arduino IDE. So you need to be able to do this in Arduino. The other part happens in Windows, but this is happening in Arduino right here, even though these are Windows instructions. So copy the link. Here, open this button, do all these things. Tools, board manager. Find the ESP32 board from the board manager. That's that box right there. This is what it looks like by Espressif. You might see that again. You know, our current version is like 3.3.0 as of like the time of this. And click Tools, Board, ESP32 Dev Module, and this is how we do it. Up here, pick that one, and Arduino IDE setting. There's supposed to be a desktop icon or something. Click that to open the IDE, but this is the IDE, right? Yeah. Okay. Anyway. To avoid errors, you need to select the correct Arduino board that matches to your computer. That took me a long ass time to figure out, but I'm using Linux and there were a few setup items that I had to chase down. I wasn't ready to make a video because I had to go sandbox for a while and figure out a couple of things. Then come back to the Arduino toolbar, select, okay, yeah, we know that. Select the COM port. Now, this is a little tricky, but I'll show you right here, right now. Get this out of the way. Let me pull up my Arduino on my view of it. So when I'm looking at the dev module, if you see this one says TTY USB 0, this one says TTY S0, right? So let's just say this is serial, this is USB, right? And you can see that here's TTY S0 serial port. TTY USB 0, that's a USB serial port. So the serial port is just the delivery versus a parallel port. You know, you're receiving all the bits one at a time versus, 10 to 15 or 16 bits at a time, however many. This is a stream of ones and zeros. So even though this is a serial port, it's coming in over USB. This would be a standard serial port, that you might have on your computer. That maybe you would connect to a plotter or something like that, different type of serial port. Meaning, if we were connected through that serial port, we would choose it, but we're using the USB. It's kind of so once again, this is what we saw. Board, ESP, dev module, we would go to if we open the board's manager, if we open the ESP32, and this is our dev module. So that's what we select, and we've got that on USB. So for whatever reason, actually it was that CH341 driver for Linux that was really throwing me off. And okay, these are some of the things that the other buttons do, and we'll figure those out later. Okay, okay. Then there's a whole set of instructions for Mac, right? So we already covered the Windows instructions. Now they send us the instructions for the Mac. So once again, there's that 340 driver. That's important to do before you get into the IDE. And this is all Mac instructions. If you have this kit and you're using a Mac, then you don't need to watch this video for it, right? But if you're just curious, like I'm not going to go through the Mac instructions. I'm just pointing out how frustrating. Oh, Okay, that's it for the Mac instructions. So our Arduino projects. This is where we're going to start following our tutorials. And but really, my whole point of that is just to complain that they didn't do anything to help us Linux users out, you know. All right, we had a little bit of dead air there. My headset turned off on me, but they didn't do anything to help guide us through the Linux installation, and that's why it took me, you know, a lot of extra time to figure out, like, okay, well, what does a CH340 driver have to do with Linux? And find out, you know, a couple hours later that that's even out of date. So, anyway, took me a while, but we got it done. So now, what I'm going to do is, right now I'm going to pause. I'm going to stop this video. And that was kind of our introduction, our makeshift introduction for lack of any other term. And I'm going to pause this, and when we come back, we're going to just start going through all of these projects one by one. And we're going to start with this LED board. Let's see. Right now, like I said, we have the LED works as we press the button, like that. But we're going to start from scratch in the next video, and we're going to go through all of these. So as an overview, what's to come? Project 1, LED blink, description. Okay, we've installed the driver for this board, right? And we connect. And then there's a working principle, and it's going to use less than 20 milliamps and about 1/10 of a watt of power. And then control pin, and this is our test code. And let's look through our code. We're going to define the yellow LED pin to 12. And then setup. So, for example, we're going to run the setup method, right? And we're not going to have it return anything. It's not going to return any, so that's why it's called void. We'll talk more about that later. Just like we're going to write this loop, and it's not going to return anything to us. It's just going to instruct, you know, the LED to blink and stuff like that. That's why it's void. If we needed it to return something else, we would have a different word there. But we don't care about the void. It's not returning any information to us. It's just telling this thing to blink. In programming, I actually forget what this word is called. I used to know it a couple of years ago, but I haven't done any programming in a while, so that's part of the reason we're doing this. And then 6, test result. We're going to upload the code. We'll see white and yellows. We'll see LEDs flashing. And then, okay, project 2, a breathing LED. What's a breathing LED? It's a phenomenon. Okay. Okay, so a breathing LED, yeah, it smoothly changes from light to dark and back, almost like a heartbeat, but it fades in and out. Continuing, give the illusion. Okay. However, how to control the brightness. So it makes sense. Okay. And this is duty cycles. We'll talk about duty cycle. This is our test code. We'll play with the test code. And then, you know, we'll get into project 2 is read the button. What happens after? Okay. Project 2, table lamp, 2.2. So what's that? When I click the button, it's going to change the state. And then read the motion sensor. Okay. So we'll read the motion sensor. And then 3.2, PIR motion sensor. If someone moves in front, the LED will light up. So it's not just the motion sensor like this. It'll be if somebody trips the motion sensor, this LED will light up. So now we're interacting. We're having an input trigger an output. around the time we get up to here, right? So well, actually, that's what this is. This input is triggering that output too, using the button. But we'll do that with the motion sensor. Happy birthday. Let's see, we have a buzzer. Let's say we'll have the buzzer play Happy Birthday, which I don't know how they got away with that because that's a copyrighted song. Um, if anybody wants to get Key Studio in trouble, they could probably rat them out and probably won't make any money off of it. But you know, probably they probably should have picked a. They probably should have picked something that was royalty free. Is all I'm saying. But that's just me being pedantic. um, okay, we got our test code. We got a music box. Okay, we'll make a music box. So Tetris, it'll play Tetris, Ode to Joy, Christmas song, and a Star War tone from that Star War. Project 5, control the door. Automatic doors and windows. Okay, so 180-degree servo, raindrop sensor, closing the windows automatically when it rains. We can add RFID, effective swiping to open a door. This will be some cool. So those are servo motors. So what's this? Around Project 5, we're starting to work with servos. And we're going to window closers. Project 6 is going to give us what? Atmosphere lamp of smart home. Huh. I'm, oh, RGB LED. Okay. So red, green, blue LED. 6.2, I think the button is going to control that, maybe. 7, we use a fan. We have a fan, and it's a DC motor fan. And then with 7.2, we'll switch the fan off and on. And Project 8, we have our display. Whoops, we have our display. We'll use that. Project 8.2, we have a dangerous gas alarm, and that's lit right now on my house. It could be just because I farted. No, I'm just kidding. I'm going to do fart, but I didn't. I said that to be a joke. Project 9, temp and humidity sensor. Project 2, RFID. Okay. 4, Morse code to open the door. Huh. That'll be interesting to figure out what we use with that. Project Smart Home. Oh, look. So, the easiest way to access the internet. It looks like then what? We have our station, which we'd be able to control through the internet or through our PC. That's what I'm doing right now. Okay. No, wireless though. That's what this is. The Wi-Fi module. Okay. Sorry, I had to figure that out. And what? ChinaNet. We're gonna ChinaNet. Okay. Oh, look. And the result of that will print. Okay, Project 3. Mobile phone app. Okay, so there's an Android app that comes with this, and we'll connect it to our phone. And that's the code to do that. Oh, so that's actually why when I first loaded up the app on my phone, it didn't work and it didn't look complete and it didn't really do anything at all. It looked like halfway broken. This is why we have to finish it. I did not know that. Okay. So we have to connect it using this code. Okay. So that's our overview. And oops. Oopsie, so we can open that up again. But that's our overview, and that's what we're going to be looking at in the near future. And we'll start in the next video.